JMath.
Welcome to a video on trig graphs. So this is just going to be a quick overview of everything you need to know before we start with the more difficult and advanced questions. So what you see on screen is a sine graph. So I'm just showing you between 0 and 360. So it first goes up, back to the middle, and then down to a turning point, and then back to 360. That means its period is 360 degrees, which means it completes one cycle in 360 degrees. The amplitude is 1, and remember, amplitude just says from the middle of the graph, how far does it go up or down? So if the middle of a sine graph is 0, it went 1 up to a turning point and it went 1 down to the other turning point. The range is therefore -1 and 1. So why am I showing you this? You need to know the standard form of a sine graph, cos graph, tan graph, because then it will be so much easier when the advanced questions come and they ask you what changed or how did this one transform into this one. So please just have a general idea of what all the graph looks like, and then the questions that follow will be so much easier. A cos graph is what I'm showing you now. So everything is exactly the same as sine. It just moved a little bit to the right or the left. So that means it doesn't start at 0, 0 this time. It actually starts at the maximum value of 1 at 0. So for all the Afrikaans people, I would always say, as jy kos soek, gaan haal 'n bakkie. So a cos graph forms a little bowl. So everything stays the same. Period 360, amplitude is 1, range is -1 to 1. So remember, if you want some kos, go get a bakkie. The next one is the tan graph. So this one is the odd one out. So in this case, there are no turning points because it just keeps on going up and it keeps on going down. But for a tan graph, there are asymptotes everywhere. So at 90 degrees and then spaced out every 180 degrees, there will be an asymptote. So that means the graph goes very far up to infinity, but it never crosses that asymptote, and it goes very far down to minus infinity, but it never crosses the dotted line. So that we call an asymptote. Now, a tan graph repeats every 180 degrees, so not 360 like the others. And in this case, if they ask you what is the amplitude of a tan graph, you can tell them not applicable or none, because amplitude measures the distance between the middle of a graph to its maximum value. There is no maximum value, so therefore not applicable. The range is an element of real numbers. That means y extends from minus infinity to positive infinity. You can't say where it starts and where it ends. That is a tan graph. So here you can see all the variables that can change with a sine, a cos, or a tan. So I'm only showing you sine, but the values stay the same for sine and cos, and with tan, just a few things change, but I'll tell you when we get there. A mainly tells you two things. Is the graph the right way up? Or if A is minus, the graph will be upside down. Okay, so that's why it's important to know your original graphs. A then also tells you what is the amplitude. So if A is 3, the amplitude is 3. And if A is maybe -2, it's upside down, but the amplitude is still 2. You can use this formula you see to work out A if it is a bit complicated and you can't just see the value. The b value of a trig function influences the period. So a normal b value is 1, and then the period is 360 for sine and cos. But if b is, for, let's say, 3, then the period would be 360 divided by 3. If b is a half, then the period would be 360 divided by a half. So it stretches or squashes the graph. You can use these two formulas you see to work out what the period is if you know b, and to work out b if you know what the period is. The p-value tells you if the graph moved a little bit left or a little bit right, but it's very tricky. It's always opposite to what you see. So if the graph moved right, the p-value is actually negative. And if it moved left, you need to put a plus in front of the p-value. And lastly, the q-value tells you if the graph moved up or down. So in this case, no tricks. Up is plus, minus is down. And if it is tricky, because sometimes they're going to change a few things and it's not just clear what the q-value is, then you can use this formula that you see. Now we're going to have a look at a tan graph and how it affects everything that changes. So firstly, the a value. So we don't have an amplitude, but it does stretch the graph out and it flips it upside down if a is negative. The b value now affects the period, which also affects the asymptote. So as b gets bigger, the graph gets stretched, and as b gets smaller, it gets squashed, and the asymptotes get closer together. So remember, a period for a tan graph is 180 because the distance between asymptotes are 180. Now for the p-value, it just shifts everything, including the asymptotes, a bit left and a bit right. So right is a minus and left is a plus. If we look at the q-value, it just shifts everything up and down. So we normally look at the middle of a tan graph to see what the q-value is. Did it move up or down? Because we don't have a maximum or a minimum. Now you know what the standard graphs look like and what all the extra variables mean. So in the next video, we are going to practice sketching the graphs. Then in the next one, we're going to find the equation. And then lastly, we're going to end off with a video about exam type questions and exactly what you can expect. Please go through this part of the playlist and then try the video at the end where we do exam level questions to see if you really understand what's going on here. This can be quite easy marks. There's only 1 or 2 trick questions, but the rest should be free marks for you in this section.
If this video helped you, please like and subscribe.
JMath.